Miss Puck from Mirror Lake. Thanks for joining. Do you notice anything different about my background today? That's right, if you've joined us, we have the books we've read. Oh my goodness, there's a whole long list that we're going to continue adding to with the authors, of course, and then the skills we've been learning throughout this whole time together. So awesome job, whether you've tuned into all of them or tuned into some. Way to go. I'm so proud of your hard work and doing this with me. And we're going to just keep adding to this. So way to go. I'm so proud, guys. Keep it up of those skills. So let's go ahead and read the target so we can continue adding more to that. Go ahead and read with me. I will make a prediction about what happens next. So remember, in a prediction, a good sentence stem is I predict blank will happen because blank. And make sure you have evidence or a reason for your prediction. We don't want to just guess anything random. It has to kind of make sense throughout the story. But guess what? It is okay if you're wrong on your prediction. Good readers just want to kind of think ahead and think about what's going to happen. It's sometimes fun to guess and see if you're right or wrong. Let's get started. So remember, a prediction is what you think is going to happen next. It's okay if you're right or wrong as long as you have evidence to support your thinking. So remember, a good sentence stem is I predict blank because blank. So a couple hints for you while we're reading today. Look at the picture clues and see if anything helps us. And then look at also what the character says or does or their actions. Sometimes that helps and gives us a clue to make a good prediction. Are you ready? So you may or may not have read this book before or heard this book, but this is one of my personal favorites called Those Shoes by Mary Beth Bolts. Now, it's harder to make predictions if you've read this book before, but if you're like me and have a not great memory, maybe you don't remember how this ends, so you can continue doing some predictions along with us. If you haven't, get ready for one of my favorite personal books. I have dreams about those shoes. Black high tops, 2 white stripes. I'm going to pause and let you see the pictures because this is a bigger book. Grandma, I want them. There is no room for want around here, just need, Grandma says. And what you need are new boots for winter. Brandon T. comes to school in those shoes. He says he's the fastest runner now, not me. I was always the fastest before those shoes came along. Nate comes to school in those shoes. Antonio and I count how many times Nate goes to the bathroom. 7 times in one day, just so he can walk up and down the hall real slow. Next, Alan, Jacoby, and Terrence each get a pair. Take a look at those shoes. Then one day, in the middle of kickball, one of my shoes comes apart. Looks like you could use a new pair, Jeremy, Mr. Alfrey, the guidance counselor, says. He brings out a box of shoes and other stuff he has for kids who need things. He helps me find the only shoes that are my size, Velcro, like the ones my little cousin Marshall wears. They have an animal on them from a cartoon I don't think any kid ever watched. So even by his attitude, can you predict how this is kind of an inference, you're thinking how he's feeling. Does he feel excited about the shoes? What do you think? From what I've heard, him saying, he's like, those are what my little cousin wears. And then the look on his face, does he look super happy and excited? Not really, not to me. And I'm trying to predict about what happens when he goes into class with those shoes. What do you think? You can keep that in your mind and see if you're right. When I come back to the classroom, Alan Jacoby takes one look at my Mr. Alfrey's shoes and laughs, and so do Terrence, Brandon T., and everyone else. The only kid not laughing is Antonio Parker. You see him there. At home, Grandma says, how kind of Mr. Alfrey. I nod and turn my back. I'm not going to cry about any dumb shoes. but when I'm writing my spelling words later, every word looks like the word shoes, and my grip is so tight on my pencil, I think it might burst. You can see that there. I'm wondering how he's feeling with his tight grip on his pencil, and then he says he's not about to cry. Doesn't seem very happy to me. On Saturday, Grandma says, let's check out those shoes you're wanting so much. I got a little bit of money set aside. Might be enough. You never know. He looks hopeful here. At the shoe store, Grandma turns those shoes over so she can check the price. When she sees it, she sits down heavy. Maybe they wrote it wrong down, I say. Grandma shakes her head. I'm going to pause and think about predictions here. I predict, what do you think might happen next? And because, why? What's your evidence? Do you think Grandma's going to get those shoes? Or do you think she might not get those shoes? It's sounding like they're kind of pricey. Would you agree? Here's some clues. She's sitting down heavy. She just plops down on that bench, and she's does her face look super happy? I don't know. And he's trying to be helpful, saying maybe they wrote it down wrong. And she's thinking, I don't think so. Then I remember the thrift shops. What if there's a rich kid who outgrew his or got 2 pairs for Christmas and had to give one of them away? We ride the bus to the first thrift shop. Black cowboy boots, pink slippers, sandals, high heels, every kind of shoes except the ones I want. We ride the bus to the second thrift shop. Not a pair of those shoes in sight. Around the corner is a third thrift shop. I see something in the window. Can make a prediction here. Do you think he finds them? Are they his size? Thinking about what's going to happen next. Now I wonder if a good prediction is, I predict a dinosaur is going to come and eat them. Is that a good prediction? It's a guess, I guess. It's not a good guess because I have no evidence to prove. There has been no dinosaurs in this story, and that just makes no sense. So I would say, Miss Pack, that's not a very great prediction. And I have no reason to think that. Hey, black shoes with 2 white stripes, high tops, perfect shape, $2.50. Those shoes. My heart is pounding so hard as I take off my shoes and hitch up my baggy socks. How exciting, Grandma says. What size are they? I shove my foot into the first shoe, curling my toes to get my heel in. I don't know, but I think they fit. By the look on his face and then him curling his toes, do you think they fit? It looks like it might not fit to me. Grandma kneels on the floor and feels for my toes at the end of the shoe. Oh, Jeremy, she says, I can't spend good money on shoes that don't fit. Make a prediction here. Do you think Grandma's going to buy it for him? And then why would you say that? Think of your because. What's your reasoning? I pull the other shoe on and try to walk around. They're okay, I say, holding my breath and praying that my toes will fall off right then and there. Do they fit? No. But my toes don't fall off. I buy them anyway with my own money, and I squeeze them on and limp to the bus stop. I know I've worn shoes before that are too tight, and it is not a good feeling. But he really wanted those shoes. So look at his bedroom. At home a few days later, Grandma puts a new pair of snow boots in my closet and doesn't say a word about my 2 big feet shuffling around in my 2 small shoes. If you notice here, he has some Band-Aids on his poor little feet. Sometimes shoes stretch, I say. Grandma gives me a hug. Do you think they're going to stretch to fit his feet? I don't know. I check every day, but those shoes don't stretch. I have to wear my Mr. Alfreys to school instead. One day during math, I glance at Antonio's shoes. One of them is taped up, and his feet look smaller than mine. You can see them kind of falling apart there. After school, I head to the park to think. Antonio is there, the only kid who didn't laugh at my Mr. Alfrey shoes. You can see the detail. And I would want to pause here and make a prediction. What do you predict is going to happen next? And then what's your reasoning? Because I would love to hear from you if I could, if you guys were in person, but I want to take a look at the picture clues and thinking about what the character is saying. So Jeremy, he's noticing that his feet are all taped up and then his feet look smaller than his. And then he's noticing and he's recognizing, hey, he was the only one who didn't laugh at me when I came in with those shoes or with the Mr. Alfrey shoes. What do you predict? Are you thinking about it with a reason? Let's find out. We shoot baskets. A loose piece of tape on Antonio's shoe smacks the concrete every time he jumps. I think I'm not going to do it. We leap off the swings. I'm not going to do it. We race from one end of the playground to the other. I'm not going to do it, I say. Do what? Antonio says, breathing hard. What do you think he's talking about? What's Jeremy talking about saying, I'm not going to do it? What is he not going to do? Keep that prediction in your brain. It's fun to think, oh, what's going to happen next? And see if you're right. It's okay if you're wrong, but you can check. Grandma calls me for supper and invites Antonio over too. After supper, he spies my shoes. How come you don't wear them? Antonio asks. I shrug. My hands are sweaty. I can feel him wishing those shoes were his. Do you think right now that Jeremy wants to give him the shoes? And then what's your reasoning about why? And do you predict that he's going to give him the shoes? And why? That night, I am awake for a long time thinking about Antonio. When morning comes, I try on my shoes one last time. Making predictions here. What do you think he's going to do with those shoes? I wonder, would this be a good prediction? I predict, Jeremy's going to throw those shoes away. Is there evidence to show that he would do that? I don't really have any proof that he would do something like that. Or do you predict, hey, he might give them away? And then who do you think he'd give them to? And then we have some reasonings there, right? He was saying, I'm not going to do it. And what do you think he's thinking about not giving it away? And then he also tries the shoes on at his house. And I wonder why he tried it on one last time. Before I can change my mind, the shoes are in my coat. Snow is beginning to fall as I run across the street to Antonio's apartment. Is your prediction right? I put the shoes in front of his door, push the doorbell, and run. What did he do? Jeremy gave those shoes that he bought with his own money and that he wanted, he gave them to Antonio because he had shoes that weren't were very worn out as well. At school, Antonio is smiling big in his brand new shoes. I feel happy when I look at his face and mad when I look at my Mr. Alfrey shoes. So it's looking like, and it's saying here, he's happy that he did something kind for a friend, but then he's also kind of bummed that he doesn't have those shoes. But later, when it's time for recess, something happens. Everywhere there is snow. Leave your shoes in the hall and change into your boots, the teacher announces. Leave your shoes in the hall. It's then I remember that I have what I have in my backpack, new black boots that no kid has ever worn before. Standing in line to go to recess, Antonio leans forward and says, "Thanks." I smile and give him a nudge. Let's race. I wonder, were your predictions correct throughout the story? And did you have evidence to support it? Remember my silly example about a dinosaur coming and eating Grandma and Jeremy? There was no evidence for that. So that was not a good guess. Even though it was a guess, I had no proof or evidence of that in the story at all. Not in the pictures and not even in the words. So that was not a good prediction. However, I wonder if some of you already knew that Antonio had a good heart, and I know he was kind of holding on to those shoes and he wanted to keep them for himself, but in the end, he did give them away. So let's fill out this SWIBs together. The somebody in wanted but so. Remember, this is a great comprehension tool just to check on your own if you understand, or parents or big brothers or sisters if you're watching. You can always ask your person to find the SWIBs of a story that they've read just to make sure they understand what's going on. So I already filled out part of it. So Jeremy was the main character. He was at home and at school, but I just chose at school because that's where he really wanted the shoes. Wanted, and we all know he wanted those new shoes, but the main problem was he bought ones that were too small. So, and you could have had a different problem here. I think that would have been correct as well. Because remember, Miss Pock this is not the only way that is correct. But help me finish this one. So remember, we have to finish not finish, excuse me. We have to connect the problem and the solution. So, but he bought shoes that were too small. So what did he end up doing? What did he do? Did he give them away? Did he throw them away? What did he do? So he gave them, do you remember the character's name? That's right, that was Antonio, his friend. And if you weren't sure, you could always, again, go right back to the text. I always have my book handy next to me. So we just wrote the SWIBs, a very quick summary on that book, one of my favorites. And then really quickly with the lesson and central message, remember that's what the author wants you to learn. And I just put be kind. I kept it simple, or it's nice to do some things for other people. Here's some of my evidence from the text to support that. Jeremy gives away the shoes he wanted to a friend. And then Antonio doesn't laugh or make fun of his shoes. So both of them, in a sense, are being super kind to one another and being friendly. And I know that sometimes it's hard to do something nice for someone. I know I've been in Jeremy's situation before, but in the end, it does work out. So I'd like you to think about what's something you can do for somebody else today.
Hello again, and happy Monday to all you math problem solvers out there. Welcome back. If you're new, I'm Mrs. Nelson. I have been on a summer math journey, doing some lessons to teach important math skills that we need to know. And if you have been watching the other episodes and lessons I've done so far, we've been exploring multiplication and division. So these last few weeks, we've talked about what multiplication and division are, different strategies we can use to solve problems in math that involve multiplication and division. And last week, we went through some special rules that we can remember and use that are just more tools and strategies to help us when we're solving multiplication and division facts. This week, we are going to move into kind of refining our skills and becoming more fluent with multiplication and division. And that just means that we are going to actually start to become automatic with knowing what we need to do when we see a multiplication or division equation. So we can write in the missing numbers, whether the numbers we're writing in are the factors in a multiplication equation, the product or the answer. In a division equation, we might be writing in the answer, the quotient, or other missing numbers like the divisor or the dividend. So this week we're talking a lot about becoming fluent with our multiplication and division facts. And today we're going to look at how we can think about the relationship between multiplication and division and how we can use that to help us solve multiplication and division equations and figure out the numbers that are missing in an equation. So that's our goal today, and I'm excited to get started with you. So I will show the whiteboard with the learning target on it in a moment so you can see what your actual target is for today's lesson. But first, I wanted to talk about the relationship between multiplication and division. And if you've watched some of the other lessons I've already taught, you might have heard me already kind of talk about this. So hopefully this isn't totally new to you, but even if it is, what I mean by the relationship between multiplication and division is that they are inverse operations. So that's a new word for today, inverse. And inverse operations in math are just operations that are opposite. So they're like undoing each other is kind of how I think about it. And I made this little poster to help us think about which operations in math are inverse of each other. So you might be familiar with adding and subtracting. See, the plus sign is what we use when we're adding and the minus sign for subtracting in math. And those are also inverse operations, just like multiplication and division, because we're doing the opposite step when we're using each of those operations. So when we're adding, we're putting two numbers together. We're putting two values together to make a total. When we're subtracting, we're starting with one number and we're taking away from it so that we have less than what we started from. We're breaking that total that we started with apart. Multiplication and division, it's kind of the same thing. In multiplication, we're taking equal groups and putting them together. And in division, we're taking a big total and we're splitting it apart into equal groups. So one of the TPR hand signals that I've used that I like to use and think about when we're talking about multiplication and division is taking your two hands. Think of them as like two equal groups, right? We have 5 fingers on each hand. And to show multiplication, we can move them together like this. So we can say multiply, putting equal groups together. Another cool thing is it kind of makes that multiplication symbol with my thumbs because they're crossing like an X. So multiply, putting equal groups together. And divide or division just means take a total, split it into equal groups. So when we multiply, we're putting equal groups together to find a total. When we divide, we're splitting up a total into separate equal groups. So that is the relationship between multiplication and division, and that is why they are inverse operations, or opposite of each other. One of those operations, multiplying, we're finding a total, we're putting groups together. And the other one, we're splitting a total into smaller groups. I actually have kind of the big goal of our week this week, of all 4 lessons we're doing this week, which, as I said earlier, is to be fluent or be able to fluently multiply and divide within 100. So that just means we know how to solve all of our multiplication and division equations from 0 times 0 all the way up to 10 times 10 equals 100. And we can do that using different strategies, like the strategies I've already taught and shown you over the last couple weeks, and also by understanding what we're talking about today, how multiplication and division are related, the relationship of multiplication and division together. Then down here, it's just showing you that the end goal for 3rd grade math problem solvers is that by the very end of the year, we know all of our products multiplying 2 factors together almost from memory. We almost have them memorized because we've worked with those factors so much. So this is just to show you kind of the end of year goal for 3rd grade and just the big idea that we're exploring this week. Here I have a word wall just to go over some really important words that we'll be using, talking about, and thinking about today specifically and throughout the rest of the week. So just a reminder, we've already discussed multiplication and division and what those words mean. So you can read those definitions again. I want to go over what factors are, just because you'll be hearing me say that word today. And that's just what we call those 2 numbers we're multiplying in a multiplication equation. So in this example, 2 and 4 are our factors in 2 times 4 equals 8. Inverse is the word you just heard me use a moment ago, and that is just a word for opposite. And we think about inverse operations in math are operations that are doing opposite things. And today we're talking about how multiplication and division are inverse of each other. Our operations, that word just is what we call what we do with our numbers in math based on what symbol we see in the equation. So we in 3rd grade math typically just use these 4 operations: add, subtract, multiply, and divide. And today we're talking about multiplication and division specifically. The new word at the bottom on our word wall here, or words, is fact family. And a fact family is what we call all the possible equations that show how 3 specific numbers are related through multiplication and division. And we'll talk a little bit more about fact families as we explore our lesson today. Your learning target here on the whiteboard is to show that you understand how multiplication and division are related. The goal of today is that you will be able to look at a multiplication equation and write the division equation that is related, and then draw a picture of equal groups or an array to show or represent those related multiplication and division equations. So that's our goal for today. And on the screen here, I have an example multiplication equation. I haven't written the product or the answer in yet, but this is 2 times 3 equals blank. And just a quick review on a multiplication strategy we learned that we could use to figure out what 2 times 3 or 2 groups of 3 is equal to. I could draw a little array showing 2 rows of 3. And I see that in 2 rows of 3 dots, I have 6 dots altogether. So 2 times 3 equals 6 is the multiplication equation that I was thinking about. If someone asked if I could write the division equation that is related to 2 times 3 equals 6, what that means is, since multiplication is finding the total and division is splitting the total apart, I need to look at this multiplication equation that I had and think about what my total was, what my product was. And we looked at the array to see that, and we wrote it here. The total was 6. So my related division equation should start with 6. It should always start with the total. And then I can actually decide where those other two numbers, my other two factors in the original multiplication equation, should go. So I can either divide 6 divided by 2, or I could write 6 divided by 3. This just means if I started with a total of 6 and I split it into 2 equal groups or into groups of 2, you can think about it either way, then I would have, if I wanted to do 2 equal groups, I would have 3 in each group. So my other number in the related division equation that comes after the equal sign would be 3. I hope you're noticing in these two related equations that we're working with the same 3 numbers. The only thing that changed was the order those numbers go in, where they are in the equation based on what they mean. So in our multiplication equation, 2 times 3 meant we were thinking about 2 groups of 3. And that was equal to 6 in total, or 6 altogether. So to write the related division equation, I took that total and started with the total. And then remember, the division symbol is just a line with a dot above and a dot below. And then I decided to divide 6 by 2, to divide it into 2 equal groups. And I see that when I do that, I have 3 in each group. So this is an example of how I could take a given multiplication equation and write the related division equation. 2 times 3 equals 6 was my multiplication equation, and my related division equation is 6 divided by 2 equals 3. Okay, so now it is your turn to try. I'm going to show you a multiplication equation, and I would like you to write a related division equation and draw an equal groups picture or an array to represent or show the two equations. So you're going to need to grab a paper and a pencil or something to write with if you don't already have those tools. And in a moment, I'll show you your problem. So here is the problem that I would like you to try on your own. It says to look at the multiplication equation below and write a related division equation. Then draw an equal groups picture or an array to show this fact family. So I mentioned earlier fact family, and that is just all of the possible multiplication and division equations that are related, showing how 3 numbers are connected. And so all I want you to worry about today is being able to write the related division equation. But as a bonus challenge, if you think you can figure out the other multiplication and division equations that you could also write to show how those 3 numbers are related, that could be another challenge to try. Your goal, though, for this problem is mainly just to be able to fill out at least one related division equation and draw a picture to represent. So do your best, and we'll go over the answer in just a moment. To check your answer and see how you did on writing the related division equation for 3 times 5 equals 15, and a picture that represents or shows 3 groups of 5 as a total of 15, you could have drawn an array, and this example just shows 3 equal groups. Also, something to know is it's okay if instead of writing 15 divided by 3 equals 5, You might have written 15 divided by 5 equals 3. The 3 and the 5 could be switched around and it would still be correct. The most important thing is that you're starting with 15. You're always going to start with the total in a division equation. Now, just to show you, if you tried to write the other two equations that also show how these three numbers are related, you could have written 5 times 3 equals 15. So that's a review from last week. If you remember, we talked about the commutative property, which just says that you could switch around two factors in a multiplication equation and the product will stay the same. So the other multiplication equation in this fact family would be 5 times 3 equals 15. And then, as I mentioned, the two possible division equations would either be the one I wrote here, 15 divided by 3 equal to 5, or 15 divided by 5 is equal to 3. And we just call this a fact family, these four equations, because they are the four equations showing how those three numbers, 3, 5, and 15, are connected through multiplication and division. So check how you did. Mainly, I just want you to check and see, did you do a nice job writing the related division equation and the drawing a picture? And then down here was just the two other equations for the fact family as a bonus. So today we talked about how we can use the relationship between multiplication and division to help us solve and write missing numbers in equations. So we just talked today about how multiplication and division are inverse operations. They're the opposite of each other. And multiplication just means putting equal groups together. Division just means splitting a total into smaller equal groups. So we did some practice where we looked at one multiplication equation and then we wrote a related division equation. Next time, we're going to dig a little deeper into fact families and come back to some of the properties and rules and strategies that we've already looked at in practice that can help us figure out how to figure out what the missing number is when we're looking at a division or multiplication equation. So can't wait to see you next time. Thanks again for joining me today, and take care.
Hola niños y niñas, soy yo otra vez, la maestra Lorena Vázquez, con una semana nueva de aprendizaje de matemáticas de tercer grado. Como recuerdan, la semana pasada estuvimos estudiando sobre la multiplicación y sus propiedades, y también la relación con la división. Aprendimos que no importa el orden de agrupación cuando estamos multiplicando ni los grupos. Esta semana vamos a continuar ese aprendizaje y aprender más sobre la relación entre la división y la multiplicación. Así que si están listos, vamos a comenzar. Bueno, otra vez tenemos aquí, la semana pasada yo les dejé encargado un trabajito y un problema pendiente, así que vamos a resolverlo juntos para ver cuál es el resultado. Tengo aquí mi lapicera. Muy bien. Entonces, el problema decía, Alex tiene 24 dulces. Él quiere repartirlos equitativamente entre sus 3 amigos. Y como pueden ver, la semana pasada ya les había yo ayudado subrayando 24 dulces, que es información importante, y 3 amigos, que es la cantidad de personas o grupos. ¿Cuántos dulces tocan a cada amigo, le tocan a cada amigo de Alex? Tenemos 24 dividido por 3, así que una de las maneras en que podemos resolver esto es haciendo los 3 grupos, los 3 amigos, representarlos y luego ir repartiendo equitativamente los 24 dulces. Vamos a ver. Aquí están mis 3 grupos y yo puedo ir repartiendo los 24 dulces. Así que cuenten conmigo. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 y 24. Entonces podemos verificar cuántos dulces le tocaron a cada amigo de Alex contando. A ver, aquí tenemos 1, 2, 3, 4, 5, 6, 7, 8. Así que niños y niñas, la respuesta es 8. Le tocan 8 dulces a cada amigo de Alex. ¿Les salió la misma respuesta? ¿Lo hicieron correctamente? Espero que sí, y si no, sigan practicando porque la práctica hace el maestro o la maestra. Muy bien, vamos a empezar con la lección de hoy. Hoy nuestra meta es, estoy aprendiendo a identificar familias de datos, de división y multiplicación. Para tener éxito, vamos a poder usar una tabla de multiplicación para hallar los números en familias de datos. ¿Qué será eso de familias de datos? Identificar, vamos a empezar por ahí. Identificar quiere decir nombrar, señalar. Entonces, ustedes van a poder nombrar los números dentro de una familia de datos, porque una familia de datos es una serie de ecuaciones que usan los mismos números. Así como en una familia, todos son los miembros de la misma familia, estos números todos pertenecen a la misma familia de datos. Y esa, niños y niñas, va a ser nuestra palabra del día de hoy. Cuando ustedes me escuchen decir familias de datos, ustedes van a decir familias de datos, ecuaciones relacionadas. Quiere decir que están conectadas. Vamos a intentarlo. Familia de datos. Familia de datos, ecuaciones relacionadas. Muy bien. Y entonces, para la lección de hoy, como siempre, pueden tener su lápiz y papel, pizarra con marcador y una tabla de multiplicación, porque pueden ver aquí que vamos a emplear una tabla de multiplicación para poder hacer este trabajo. Así que vamos a comenzar. Aquí tenemos una tabla de multiplicación para ustedes que quizás se les haya olvidado o no recordaban o no sabían. La tabla de multiplicación tiene los factores. Del 1 al 10 es esta tabla, pero puede hacerse más grande, números mayores. es del 1 al 10. Estos números grises son los factores, son los dos números que multiplicamos. Y aquí está la X que representa multiplicar y se lee por. Así que podríamos decir 1 por 1, 1 por 2 y consecutivamente. A ver, vamos a empezar con estos dos números. Tenemos el número 3 y el número 24. En una familia de datos, ecuaciones relacionadas. Muy bien, los números están relacionados, así que vamos a encontrar la relación entre estos números. Primero vamos a encontrar este número 3 en nuestra tabla. Aquí está el 3. Muy bien. Ya que hayamos encontrado el 3, vamos a buscar el número 24 en la misma fila. Así que 3, aquí está, 24. Entonces tenemos el 3 y el 24 y como ya sabemos cómo funciona la tabla de multiplicación, sabemos que estos números están conectados de esta manera. Y del 24 podemos encontrar el otro factor que viene siendo 8. Entonces, el número que nos falta en esta familia de datos, ecuaciones relacionadas. Muy bien, es el 8. Así que la ecuación de multiplicación viene siendo 3 por 8, 24 y 8 por 3, 24. Vamos a explorar cómo se ve esto un poquito más. Entonces aquí tengo una tabla más pequeña y tengo esta casita para que nos dé una imagen visual de lo que es una familia de datos. Familia de datos, ecuaciones relacionadas. Muy bien. Y ya dijimos que en esta familia está el 24. Aquí está el 24. Está el 8 y está el 3. Así que vamos a poner nuestro símbolo. Ese es el que encontramos hace rato. El 8, el 3 y el 24. Así que una de las ecuaciones va a ser 8 por 3, 24. Muy bien, vamos a escribir eso aquí. 8, ¿saben qué? Muy bien, vamos a hacerlo de esta manera. 8 por 3, 24. Recuerden, no podemos usar otros números diferentes. ¿Por qué? Porque esta es una familia. Todos los números deben de ser los mismos. Imagínense en su propia familia, no pueden decir, este es mi hermano un día y luego escoger otro hermano diferente o un tío un día y un tío diferente. Tienen que ser los mismos números. Vamos a buscar la siguiente ecuación. A ver, aquí está el 3 y el 24. Así que también podemos decir 3 por 8, 24. Y si recuerdan, no importa la orden de agrupación. Tenemos el mismo producto. Entonces, 3 por 8, si volteamos, porque es una relación inversa, también nos da el resultado de 24. Ahora, ya tenemos dos de las ecuaciones relacionadas. Nos faltan dos. Y estas dos son de multiplicación. Si se pueden fijar aquí, estamos multiplicando. Y las dos que siguen son de división. Ahora, sabemos que la relación entre multiplicación y división es que son opuestos. Y sabemos que en esta casita todos son familia. Entonces vamos a poner los números en una orden diferente. Cuando nosotros dividimos, nosotros siempre empezamos con el dividendo. Y el dividendo es el total o la cantidad más grande. Así que la cantidad más grande, el dividendo, es el 24. Así que aquí yo ya sé que las dos ecuaciones de división tienen que empezar con 24 porque es la cantidad mayor, es la que se va a dividir. La primera ecuación no hay de otra, es el 3 o el 8, así que podemos empezar con el 3. 24 dividido entre 3 grupos me va a dar 8 en cada grupo. 24 dividido en 8 grupos me va a dar 3 para cada grupo. ¿Vieron, niñas y niñas, cómo no usamos números diferentes y todos estos hechos de división y multiplicación están conectados, relacionados? Es una familia de datos. Familia de datos, ecuaciones relacionadas. Muy bien, ecuaciones relacionadas. Sencillo, ¿no? Vamos a tomar otro ejemplo para seguir practicando juntos. Ok, de nuevo aquí tenemos la tabla de multiplicación con los factores en gris, los factores aquí en gris y el símbolo de por de multiplicación. Y en esta ocasión tenemos que encontrar el 7 y el 35. Así que empezaremos con el 7 aquí. A ver, 7. Aquí está el 7. Ahora, en la misma hilera voy a buscar el 35. No, esta no es. Ah, aquí está. Muy bien. Ahora, ya dijimos que podemos conectar estos números de esta manera, ¿verdad? En este caso sabemos que 7 por algún otro factor, el producto es 35. Así que empezamos del 35 y nos regresamos, porque recuerden que una tabla de multiplicación se unen la fila y la columna para encontrar el producto. Así que si me regreso por acá, fácilmente puedo darme cuenta que el número que nos estaba faltando era el 5. 5 por 7, 35, o como sabemos que no importa la orden de agrupación, 7 por 5, 35. Así que vamos a ver si tengo razón. Muy bien, 7 por 5, 35, 5 por 7, 35. Niños y niñas, ya tenemos la mitad de la familia en nuestra familia de datos. Familia de datos, ecuaciones relacionadas. Muy bien, vamos a ingresarlas a su casita. Aquí tengo el modelo que vamos a usar y empezamos con este, ¿verdad? Aquí está el 7 y el 35. Y aquí, entonces sabemos que 5 por 7, 5 por 7 son 35. Y lo opuesto, que viene siendo, aquí está, 7 por 5 son 35. Así que mira, no importa el orden. Primero empecé con el 5 y luego el 7. Ahora voy a multiplicar el 7 por 5 porque yo sé que el producto va a ser lo mismo, especialmente porque estamos aprendiendo que en esta familia todos los números que se van a usar están aquí. Al multiplicar y dividir 35, 5 y 7. No hay nuevos miembros de esta familia. Estos son los que están relacionados o tienen una conexión. Ahora, las siguientes dos ecuaciones son división. Así que sabemos que cuando dividimos empezamos con el dividendo o el total, la cantidad mayor. Así que la cantidad mayor entre 7 y 5 y 35 es 35. Mis ecuaciones de división van a empezar con 35 en esta familia de datos. Familia de datos, ecuaciones relacionadas. Excelente, muy bien. Y como el orden de agrupación al dividir y multiplicar no importa cuál número del 7 o el 5, cuál factor ponga primero. Entonces voy aquí, el divisor en este caso va a ser 7 y el cociente va a ser 5. Y podemos cambiarlo porque el orden no importa. Podemos hacer el divisor de 5 y el cociente sería 7. ¿Vieron qué fácil, niños y niñas? Espero que en su tabla ustedes también no tienen que dibujar esta casita si no quieren, pero a mí me ayuda a recordarme que estos todos tienen una relación, todos están conectados de alguna manera u otra. Y lo interesante de este método es que si yo sé multiplicar, eso me va a ayudar a dividir. Si yo sé dividir algo, eso me va a ayudar a multiplicar porque yo puedo encontrar la familia de esos números y así ya sé la respuesta de otros problemas. ¿Vieron? Si yo sé 7 por 5 es 35, automáticamente puedo usar este método para saber que 35 dividido por 5 son 7. Así que es un método muy útil a la hora de aprenderse sus tablas de división y de multiplicación. Bueno, entonces, me gustaría dejarlos con unos 2 ejemplos para que practiquen para el día de mañana. Pueden usar una tabla de multiplicación o si no tienen eso, pueden usar grupos iguales, una matriz, pero lo más útil de hoy era la tabla de multiplicación para que vayan practicando. Muy bien. Número 1. ¿Cuál es la relación entre 9 y 18? ¿Pueden encontrar su familia de datos? Familia de datos. Ecuaciones relacionadas. Muy bien. Y 4 y 28. Inténtenlo con sus seres queridos en su tabla, en su pizarra, en su hoja de papel y mañana listos para comprobar sus respuestas conmigo. Muy bien. Niños y niñas, hemos llegado al final de nuestra lección. Hoy estuvimos aprendiendo a identificar familias de datos. Familia de datos. Ecuaciones relacionadas. Muy bien. De división y multiplicación. Y la manera en que lo hicimos es usando una tabla de multiplicación para encontrar los números que están relacionados en estas familias. Y los pusimos en una casita para recordarnos, darnos un recuerdo visual de que están conectados. No podemos usar números diferentes. Los 3 mismos números nos dan 4 ecuaciones, 2 de multiplicación y 2 de división. Mañana, aparte de comprobar nuestras respuestas, estaremos viendo cómo usar modelos para completar familias de datos. Familia de datos. Ecuaciones relacionadas. Excelente, niños y niñas. Entonces, cuídense mucho y hasta la próxima. Adiós.